the excited atom comes to the ground state without any external inducement, called as spontaneous emission. For after some time, right? Because which is not staying in a long lifetime in a higher energy level. It definitely comes to the ground level without any external inducement. So which is called spontaneous emission. Then what is the mathematical expression for spontaneous emission? Which can be written as NSP. SP means spontaneous emission. So N spontaneous is directly proportional to N2, and which can also be written as N spontaneous, which is equal to A21 into N2. That's it. A21 is nothing but the probability transition from higher energy level to lower energy level. That's why I'm putting here 2 to 1. N2 is nothing but number of atoms in the higher energy level. Without any external inducement, they are coming. That's why I'm purposely avoiding Q, right? There is no energy to induce the atom from higher energy level to lower energy level. So that is why I'm putting here N spontaneous is equal to N21 into N2. So this is the second expression, and we are getting from spontaneous emission. That's it. And third one is stimulated emission. So what is stimulated emission? That is a very important thing. This is theoretically proved by Albert Einstein. So what is stimulated emission? So the word stimulation is nothing but we are giving an external triggering or an external inducement, that is called a stimulated emission. So in the case of stimulated absorption, we have two energy levels E1, E2. Number of atoms in the lower energy level is N1. Number of atoms in the higher energy level is N2. So most number of atoms occupied in the staying for a lifetime, particular lifetime in a higher energy level. Now we are sending the light energy h nu. This light energy interacted with the higher atom, that means excited atom. Then the excited atom come to the ground energy level with the emission of the atom. And forget to say one thing: whenever the light comes to the higher energy level to ground level, it emit a light energy. That is why this is called as a spontaneous emission. I'm missing this thing. Right. Now the sending light energy interacted with the excited atom, then comes to the ground state. Atom comes to the ground state. Now this state is vacant. Atom comes to the ground energy level with an external inducement. Whenever it comes to the ground level, this excited atom comes to the ground state, means which emits a light energy, which is called emitted photon. And another light energy comes from the probability transition from 2 to 1, that is the interacted photon. The interacted photon also emitted from the stimulated emission. So in the case of stimulated emission, there will be two photons will be emitted. One is emitted photon, another one is interacted photon. So these two photons are emitted from the transition from higher energy level to lower energy level. But in the case of stimulation, that is the very important thing, right? We are stimulating an atom to transit from higher energy level to lower energy level. That is why this thing is called as a stimulated emission. And this is the basic principle behind the laser device. So there will be an important questions arises in the students group. That is very simple. Sir, why we are choosing the spontaneous emission is the basic principle for laser, but we are using stimulated emission as a basic principle because laser, the expansion of laser is light amplification by stimulated emission of radiation. Why not? Laser is nothing but light amplification by spontaneous emission of radiation. That is the very important doubt arises amongst you, right? Because we have two type of emissions, right? That emission we use why we are using stimulated emission as the basic principle of laser. Now we are going to discuss what are the basic differences between stimulated and spontaneous emission. In your right side you have to create left side you have to create the column of stimulated emission. Right side you have to create a spontaneous emission, column of spontaneous emission. So I am telling you what are the important differences between these two processes. First one, spontaneous emission. The first point of spontaneous emission is nothing but making a transition from higher energy level to lower energy level with the emission of photons without any external inducement. That is called spontaneous emission. But in the case of stimulated emission, we can make the transition from higher energy level to lower energy level with the emission of photons, but with an external inducement. We are giving an external inducement, then only we can create a transition from higher energy level to low energy level. That is called stimulated emission. The output from spontaneous emission. Spontaneous emission வந்து வரக்கூடிய output எப்படி இருக்கும்? It's very simple. In the case of spontaneous emissions output, they are less directional, less monochromaticity, less intensity, less degree of coherence. They have that means the output from the spontaneous emission is nothing but they have a less degree of coherence, less monochromaticity, less intensity, and less directionality. But in the case of stimulated emission, we are getting the contradictory output from this spontaneous emission. That is, we have a very good directionality of light energy, we have a very good intense of light energy, we have a very good monochromaticity light energy, and we have a high degree of coherence. That is why we are choosing stimulated emission is our principle, because laser light is nothing but it's a monochromatic light, right? But in the case of spontaneous emission, we are getting a polychromatic light again, right? So we are choosing stimulated emission is our principle for laser device. So that is a very important thing why we are not choosing spontaneous emission other than stimulated emission, right? So that's it from the basic principle of laser. Now we are moving to another very important area called as concept of laser. So students, you are all now clarified about what do you mean by laser, and what is the history of laser, and what are the basic properties of laser, and what is the basic principle behind the laser device, right? Now we are moving to another very important area, that is the concept of laser. Concept of laser is nothing but if the students if you want to construct or execute a laser device, if you want to construct a laser device, means you have to concentrate on two important things. That is the thing we are discussed in concept of laser. The first important thing is population inversion. So this is the first thing you have to keep in your mind while you are constructing the laser device. And second one is metastable state. Metastable state. These are the two things you have to keep in your mind while you are constructing or executing a laser device. First we are going to discuss about population inversion. Population is nothing but the amount of people, right? Similarly here population is nothing but number of atoms or amount of atoms. So what is population inversion? It is very simple. In order to establish the situation like N2 greater than N1, that means number of atoms in the higher energy level is always greater than number of atoms in the lower energy level. That is called population inversion. You know, we have two energy levels. You are familiar with this diagram now, E1, E2, and this is N1 and N2. If you are sending all these lower energy level atoms to the higher energy level, right? They are all empty places, and all these atoms goes to the higher energy levels. This is the condition called N2 greater than N1. If you are achieving this population inversion, means if you can easily producing a laser device. Otherwise, there is no possibility to construct a laser device. That is the basic thing I want to telling you, right? So this is called population, and all these population goes to the higher energy level. Now this population is nothing but population inversion, or it is also known as inverted population. அதாவது தலைகீழ் மக்கள் தொகை populations வந்து இருக்கு, அது அப்படியே மேல கொண்டு போறோம். That is called inverted population. That is the word coined from that, right? Yeah, population inversion அப்படின்னு சொல்லிட்டு. So if you want to achieve the population inversion, means you have to achieve N2 greater than N1. So this is the condition to achieve the population inversion. This is the first important thing you have to keep in your mind when you are constructing the laser device. And second one is metastable state. What is metastable state? It is also very simple. Whenever the light energy goes to the higher energy level, so with the help of light energy, all the atoms in the lower energy level goes to the higher energy level, right? And they are not staying there for a longer lifetime. For example, 10 power minus 9 seconds. This is 1 nanosecond. This is the time they are staying in the higher energy level. For example, if the first atom goes to the higher energy level and staying there for 10 power minus 9 seconds, and after that it is come back to the lower energy level. Similarly, another atom from the lower energy level goes to the higher state, and after 10 power minus 9 seconds it comes to the ground state. So it is continuously happening, means you are not achieving the condition N2 greater than N1, because one atom goes to the higher energy level, then comes to the ground state, another atom goes to the higher energy level, another atom comes to the ground level, another atom goes to the higher energy level. So you are keeping the conditions like N1 equal to N2. This is the condition, this is the ordinary condition. But we have to maintain the condition of N2 greater than N1. Then how to achieve this condition instead of N1 greater than N2? It's very simple. That is why we are needing another stable state called as metastable state. So look at the next diagram here. This is E1 and this is E2. We are constructing another device called as metastable state. I am writing MS here. MS is nothing but metastable. So atoms goes to the higher energy level. So all the atoms here, and each and every atom comes to the ground state. You know that here the time is 10 power minus 9 seconds. But in the case of metastable state, there will be a longer lifetime. For example, 10 power minus 6 to 10 power minus 3 seconds. That means the excited atoms may be occupied the metastable state for this time. That is, which is exactly greater than E2 level. Therefore, we are collecting all the ground level atoms to the metastable state. Now, all these atoms simultaneously comes to the ground state means it will exhibit a very powerful light of laser source. So that is the basic principle behind the metastable state. So in order to achieve the laser device, in order to manufacturing the laser device or constructing the laser device means you have to concentrate on metastable state. If metastable state does not exist means there is no population inversion. If there is no population inversion means there is no laser execution. So that is the important thing. This is the thing I want to tell you in concept of laser. So if you want to produce a laser light, you have to achieve the metastable state first. There is no metastable state, there is no population inversion. If you are achieving the population inversion, you can easily execute the laser. If you are not achieving the population inversion, you are not executing the laser device. So these are the very important things, and they are interconnected with each other. Metastable state definitely exists. Otherwise, population inversion is not possible. Population inversion is definitely exists. Otherwise, laser execution is not possible. So they are all interconnecting: metastable state, population inversion, and laser execution. These three things are interconnected and very important, right? So this is called as a concept of laser. Now we are moving to another very important area now, pumping methods, right? So I hope you all understand the basic things of nature. That means basic things of laser. That is, what is laser device? What is the basic properties of laser? What is the basic principle behind the laser? And what is the concept behind the laser device to execute? Or a laser device execute பண்ணும்போது what are the concepts are very important? Population inversion, metastable state, right? Now we are moving to very important area. Another very important area: pumping methods. Pumping methods. Pumping is nothing but the process of raising more number of atoms from lower energy level to higher energy level. Thus, that process is nothing but pumping methods, right? So we have to achieve the condition of population inversion. So that is N2 greater than N1, right? So if you want to achieve the population inversion means you have definitely you have a method to pump the atom from lower energy level to higher energy level. So that is called a pumping method. And 5 different pumping methods are available universally to pump the atom from lower energy level to higher energy level. So what are the pumping methods? First one is optical pumping. And second one is direct electron excitation. So this is the second method to pumping the atoms from lower energy level to higher energy level. And third one is inelastic atom collision. This is the third method to employ pumping methods. And the fourth one, direct conversion technique. Direct conversion. This is the another method of pumping. Direct conversion method. And last but not least, the final method is chemical process or chemical method. So So these are the 5 important ways to achieve the condition of population erosion through the pumping methods, right? First of all, what is optical pumping? We know, again we are going to the energy level diagram. This is E1 and this is E2, right? When you are applying the light energy interacted with the atom, this means optical pumping. When you are using light energy to excite an atom from lower energy level to higher energy level, to pump the atom from lower energy level to higher energy level, called as optical pumping. Example for optical pumping is ruby laser. The first laser invented by Theodor Neumann is employed with the help of the pumping method, optical pumping. And the second pumping method is a direct electron excitation. What is a direct electron excitation? Again, we have an energy level diagram, lower energy level and higher energy level. There will be a number of atoms in the lower energy level. They are excited to the higher energy level with the help of the electron, not from light. If you are sending the light electrical energy, highly accelerated electrical field, that electrical field interacted with the atom, then atom excited to the higher energy level. This type of pumping methods is nothing but direct electron excitation. So what are the examples for direct electron excitation? It's very simple. CO2 laser, carbon dioxide laser, is a very popular invisible laser, and this laser is an example for direct electron excitation. And the third one is inelastic atom-atom collision. It is less. They have a lesser difference from direct electron excitation. These two methods are very similar, but there will be a small correction for inelastic atom-atom collision. Again, we have an energy level diagram, E1 and E2. So we are considering two atoms here. One is considering as A, another one is B, and this is also E1 and this is also E2. So we are using two elements here, two gaseous molecules. For example, if you are sending the light energy, electrical energy, this electrical energy interacted with the atom A, and atom A excited to the higher energy level, and this can be written as A plus electron, which gives A star plus electron. That means atom A interacted with the electron, then goes to the higher energy level, that is indicated by the letter A star. So atom excited to the higher energy level. This excited atom interacted with the element B. That means it interacted with the another element, another atom. So A star interacted with the atom B. Now the atom B excited to the higher energy level. Now atom B excited to the higher energy level. So this is called B star. So this can be written as this with the help of this equation. So this process is nothing but inelastic atom-atom collision. This is called inelastic atom-atom collision. So an example for this type of pumping method is very simple. You all know about the first two lasers, and the second laser is helium-neon laser. We are using helium and neon here. First of all, helium excited to the higher energy level, then helium inelastically interacted with the another element neon, then neon goes to the higher energy level. So this is the equation for that. So the three important pumping process we discussed. Now we are moving to another important pumping method, direct conversion technique. And I think you are all clear about pumping methods, right? Any doubt you can ask me after the question, after this session, right? Now, we are moving to the fourth important part of pumping method, direct electron excitation. Sorry, direct conversion. Direct conversion. The name itself explains what is a direct conversion technique. That means the electrical energy directly converted into light energy. Light energy. This is called direct conversion method. Direct conversion method is nothing but electrical energy directly converted into light energy. In what material these things are happen? It's very simple. They can happen in direct band gap semiconductors. Not in every material, particularly in direct band gap semiconductors. I'm giving you some examples for semiconductors: gallium arsenide, gallium aluminum arsenide, indium phosphate, indium aluminum phosphate, etc. So these are the direct band gap semiconductors. These type of semiconductors can have the capability to convert the electrical energy into light energy directly. So that is why this type of pumping method is nothing but direct conversion technique, right? Electrical energy directly converted into light energy. And of course, I am telling you what is semiconductor. We know that solid can be classified into three major categories: conductor, semiconductor, and insulator. You know that conductor is nothing but it can conduct heat as well as electricity very perfectly. That is why they are called as a conductor. Insulator, just opposite to conductor, it cannot conduct heat as well as electricity. That is why they are called as an insulator. And the intermediate material between these two is semiconductor. What do you mean by semiconductor? It may conduct or may not conduct. The electrical resistivity of the semiconductors is exactly lies in between conductor and insulator is nothing but semiconductor. So these are the materials. Example for semiconductor. These semiconductors definitely converting the electrical energy directly into light energy. So this is called direct conversion technique. And final method of pumping method is chemical process. Chemical process is nothing but the chemical reactions. Due to some chemical reaction, there will be a light energy exhibited in some of the chemicals. For example, hydrogen fluoride, selenium dichloride, etc. These are the things, right? In these liquids or in these chemicals, due to chemical reaction, it will produce a light energy. So this is called the chemical process. So we are explaining all the pumping methods available to pump the atoms from the lower energy level to higher energy level. So these are the 5 pumping methods. It's a very important topic how to know about laser, right? Now we are moving to another very important area, basic components of laser system. So if you are going to decide that you have to produce, you have to manufacture, you have to construct a laser device, means you have to know about three important components to construct the laser device. What are the important components? One is, wait a minute, basic components needed to construct the laser device. First one is active medium. Second one is pumping method. And third one is optical resonator. So these are the three important parts. These are the three important components when you are going to manufacture or design a laser device. So first one is active medium. What is active medium? Active medium is nothing but it may be a solid, liquid, gas or chemical or anything. That is called active medium. Where the active medium definitely exposed to light energy. That is called active medium. The material who is exposed to light energy is nothing but active medium. That active medium may be solid, liquid